Welcome to the global defense battle.
The Admiral Gorshkov-Class frigate, developed by Russia, is one of the most advanced surface warships in the Russian Navy. Built by Severnaya Verf shipyard, this class succeeded the older Frigate-class frigates and was designed to serve as a multi-role combat vessel. Its primary role includes anti-air, anti-surface, and anti-submarine warfare, while also being capable of long-range strikes and fleet escort missions. The development of the Admiral Gorshkov-class began in the early 2000s, with the first ship, Admiral Gorshkov, being commissioned into service in 2018. These frigates were developed to modernize the Russian Navy and reduce reliance on Soviet-era designs, offering enhanced stealth features, advanced radar systems, and versatile missile capabilities. On the other hand, the FREMM-Class frigates are jointly developed by France and Italy, representing a collaborative effort between Naval Group France and Fincantieri, Italy. These frigates replaced older models like the Georges Legs-class and Mistral-class. The FREMM-Class serves as a versatile platform for anti-air, anti-surface, and anti-submarine operations, with specialized variants tailored to different mission types. The development began in the early 2000s under the FREMM program, and the first frigate was commissioned in 2012. Known for their modularity, stealth design, and advanced combat systems, FREMM frigates are considered among the most capable European naval assets. And today, we will compare both of these frigates, Russia's Admiral Gorshkov versus France and Italy's FREMM-Class frigate. So, let's start. Talking about the design and dimensions first, the Admiral Gorshkov features a stealth-focused hull design, incorporating angular surfaces to reduce radar cross-section and enhance survivability in modern naval warfare. The superstructure is built with composite materials, ensuring a low radar signature while maintaining structural strength. The ship's deck is streamlined, with an integrated mast housing advanced radar systems and sensors. The hull is built to endure harsh sea conditions while supporting advanced weapon systems and helicopters. The frigate has a length of approximately 135 meters, a beam of 16.4 meters, and a draft of 4.5 meters. It has a full displacement of around 5,400 tons. The crew size is about 210 sailors, including officers and enlisted personnel. The design prioritizes advanced automation, allowing for reduced crew requirements compared to older Russian frigates. The ship also includes a large flight deck capable of housing AKA-27 anti-submarine warfare helicopter. The FREMM-Class frigates, on the other hand, are designed with stealth and modularity as central concepts. Their hull features a smooth, sloped structure to minimize radar reflection, while the superstructure is made of radar-absorbent materials. The design includes a large deck area, integrated sensor mast, and a compact bridge, ensuring optimal command and control capabilities. FREMM frigates are slightly larger than their Russian counterparts, with a length of around 142 meters, a beam of 20 meters, and a draft of 5 meters. They have a full displacement of approximately 6,700 tons. The crew size is relatively smaller at 145 to 165 personnel, thanks to extensive automation and advanced onboard systems. Additionally, the ship features a large hangar and flight deck to accommodate an H-90 helicopter. Overall, both frigates excel in stealth design, but the FREMM emphasizes modular adaptability, while the Admiral Gorshkov leans towards robust, heavily armed configurations. Talking about the propulsion and performance, the Admiral Gorshkov uses a combined gas and gas propulsion system, which combines 2 gas turbines for cruising and 2 for high-speed operations. The propulsion system includes M90F, are gas turbines manufactured by Saturn Corporation in Russia. These turbines produce a total power output of around 55,000 horsepower. This system allows the frigate to achieve a top speed of approximately 30 knots translates into 55 kilometers per hour, making it one of the fastest frigates in its class. It also boasts an impressive range of about 4,500 nautical miles translates into 8,300 kilometers when cruising at an economical speed of 14 knots. This combination of speed and range ensures the frigate can operate effectively across large distances without frequent refueling. However, the efficiency of its propulsion system is somewhat lower compared to modern Western designs, mainly due to higher fuel consumption rates at maximum speeds. On the other hand, the FREMM-Class frigates are powered by a combined diesel-electric and gas propulsion system, which is considered more fuel-efficient and quieter than traditional systems. The CODLAG setup includes 1 General Electric LM2500 Plus G4 gas turbine and 2 MTU diesel engines, coupled with electric motors for low-speed operations. This hybrid system generates a total power output of around 47,000 horsepower. The FREMM-Class frigates can achieve a top speed of approximately 27 knots, translates into 50 kilometers per hour, slightly slower than the Admiral Gorshkov-Class. However, the range is significantly superior, reaching up to 6,000 nautical miles at an economical cruising speed of 15 knots. This extended operational range makes the FREMM-Class better suited for long-duration missions and open-sea patrols. Overall, the Admiral Gorshkov-Class holds an edge in terms of top speed, while the FREMM-Class excels in operational range and fuel efficiency due to its advanced cod-lag propulsion system. Now talking about the anti-ship warfare capabilities, the Admiral Gorshkov is a formidable anti-ship platform, equipped with advanced missile systems, sensors, and radars for detecting, tracking, and neutralizing enemy ships. Its primary weapon for anti-ship warfare is the P-800 Onyx supersonic cruise missile, which has a range of up to 600 kilometers and travels at speeds exceeding Mach 2.5. These missiles are highly resistant to electronic countermeasures and can perform evasive maneuvers during the terminal phase, making them extremely difficult to intercept. In addition to the Onyx, the frigate is also capable of launching the Caliber NK cruise missile, which has an anti-ship variant with a range of up to 400 kilometers. These missile systems are housed in vertical launch system cells, allowing for quick and concealed launches. For detection and targeting, the Admiral Gorshkov-Class uses the 5P-20K Polymet radar system, a multi-function phased array radar capable of tracking multiple targets simultaneously over 250 kilometers. It is supported by the Frigate M2EM air and surface search radar, which provides 360-degree coverage and can detect both low and high-altitude targets. Additionally, the ship employs the MR-90 Orek fire control radar, specifically for guiding missiles towards enemy ships with pinpoint accuracy. The integration of these systems allows the Admiral Gorshkov-Class to detect and engage enemy vessels from long distances, even in heavily contested environments. The frigate also uses electro-optical targeting systems for enhanced precision in poor visibility conditions. On the other hand, the FREMM-Class frigates are equally capable in anti-ship warfare, with a focus on modularity and adaptability across mission profiles. Their primary anti-ship weapon is the MBDA Exocet MM-40 Block 3 missile, which has a range of up to 200 kilometers. The Exocet is known for its sea-skimming capabilities, flying at extremely low altitudes to avoid detection by enemy radars. Additionally, FREMM frigates used by Italy are equipped with the Tessio Mk2A missile, also known as Odomat, with an extended range of over 200 kilometers and advanced electronic countermeasures. These missiles are guided using inertial navigation systems and active radar seekers, ensuring reliable performance against modern naval defenses. For sensors and tracking, FREMM frigates rely on the Thales Heracles multifunction radar, a rotating phased array radar capable of detecting and tracking air and surface targets up to 250 kilometers away. Additionally, they use the Celex ES Emperor radar for fire control and missile guidance. These radars are complemented by electro-optical sensors, including the Sagem Vamper NG infrared search and track system, which enhances detection capabilities in low-visibility environments. The Sirius IR-ST system provides passive detection of infrared signatures, improving the ship's stealth and tracking precision. Talking about the anti-submarine warfare capabilities, the Admiral Gorshkov is highly capable in anti-submarine warfare, equipped with advanced weapons, sensors, and sonar systems designed to detect, track, and neutralize underwater threats. Its primary anti-submarine weapon is the RPK-9 Medvedka anti-submarine missile system, which launches a missile carrying a lightweight torpedo that can engage submarines at a range of up to 50 kilometers. Additionally, the ship is equipped with Paket NK torpedo launchers, which can launch small, fast-moving torpedoes specifically designed to target enemy submarines and incoming torpedoes. These torpedoes are equipped with active and passive sonar seekers, enabling precise targeting of underwater threats. For detection, the frigate uses the Zarya M sonar system, a low-frequency active sonar capable of detecting submarines at considerable ranges, even in noisy underwater environments. It is complemented by the Vignetka sonar system, which provides towed array sonar capabilities, allowing the frigate to detect submarines from extended distances and across deeper waters. Additionally, the frigate is equipped with helicopter support, typically operating a CAMF Ka-27PL anti-submarine warfare helicopter, which carries torpedoes and depth charges and is equipped with its own sonar and magnetic anomaly detection systems. Together, these systems give the Admiral Gorshkov-Class frigate the ability to detect and engage submarines effectively in deep sea and coastal waters, providing a layered defense network against underwater threats. On the other hand, the FREMM-Class frigates are also highly advanced in anti-submarine warfare, with a focus on stealth and sensor integration for maximum efficiency in underwater detection and engagement. The frigates are equipped with Mu-90 impact lightweight torpedoes, which are highly maneuverable and capable of engaging submarines at depths of up to 1,000 meters with a range of approximately 25 kilometers. These torpedoes use advanced sonar guidance systems, making them highly accurate against fast and stealthy submarines. Additionally, some variants of the FREMM frigate can launch MILIS anti-submarine missiles, capable of delivering torpedoes over long ranges. For underwater detection, the FREMM frigate uses the Thales UMS 4110CL hull-mounted sonar, which provides active and passive sonar capabilities for submarine detection in shallow and deep waters. This is further complemented by the Capta's 4 variable depth sonar, which allows the frigate to detect even the quietest submarines operating at long ranges and varying depths. The Sagem BlueScan sonar system enhances the frigate's situational awareness underwater, giving it the ability to track multiple submarine targets simultaneously. Supporting these systems is the NH-90NFH helicopter, equipped with dipping sonar, sonobuoys, and torpedoes, allowing it to search for and engage submarines at extended distances. The combination of onboard sonar systems and helicopter support makes the FREMM-Class one of the most effective anti-submarine frigates in the world. Overall, while both frigates are extremely capable in anti-submarine operations, the Admiral Gorshkov-Class focuses on a heavily armed, multi-layered response system, whereas the FREMM-Class relies on superior sonar technology and advanced lightweight torpedoes to dominate underwater warfare scenarios. Coming to the anti-air warfare capabilities, the Admiral Gorshkov is highly capable in anti-air warfare, designed to protect itself and allied naval assets from aerial threats, including enemy aircraft, drones, and incoming missiles. Its primary weapon for anti-air defense is the Polyman Tree Dut air defense missile system, which uses 9M96E and 9M96E2 surface-to-air missiles. These missiles have an effective range of up to 150 kilometers and can target high-speed, maneuvering aerial threats at both high and low altitudes. Additionally, the ship is equipped with Cortic close-in weapon systems, combining 30mm rotary cannons and short-range missiles for intercepting threats that penetrate long-range defenses. For close-range anti-aircraft defense, it also carries IGLA-S, man-portable air defense systems, providing a final layer of protection against low-flying targets. The FREMM-Class frigates, on the other hand, also excel in anti-air warfare, with their systems emphasizing long-range detection, interception accuracy, and adaptability to diverse air threats. Their primary anti-air weapon is the MBDA Aster missile family, specifically the Aster 15 and Aster 30 surface-to-air missiles. The Aster 30 has an operational range of up to 120 kilometers and is capable of intercepting high-speed aircraft, drones, and incoming missiles. The Aster 15, with a range of up to 30 kilometers, is optimized for medium-range aerial threats and fast interception. These missiles are housed in the Silver A-50 vertical launch system, allowing for rapid and simultaneous missile launches. For close-range air defense, FREMM frigates rely on Oerlikon 76mm super-rapid naval guns and sometimes the CIWS systems like Leonardo's Dardoch IWS, which provide an additional layer of protection against close aerial threats. Overall, both frigates are highly effective in anti-air warfare, but their strengths lie in slightly different areas. The Admiral Gorshkov-Class prioritizes layered defense and raw missile range, while the FREMM-Class emphasizes precision targeting and adaptable missile systems. Now regarding the land attack, the Admiral Gorshkov is highly capable of conducting land attack missions, making it one of the most versatile surface combatants in the Russian Navy. Its primary weapon for land strikes is the Caliber NK cruise missile, which has an extended range of up to 2,500 kilometers, depending on the variant. These missiles are housed in the vertical launch system onboard the frigate, allowing rapid and stealthy launches. The Caliber missile can carry both conventional and nuclear warheads, and its terrain-hugging flight profile makes it extremely difficult to detect and intercept. Additionally, the P-800 Onyx supersonic cruise missile, although primarily designed for anti-ship roles, can also be repurposed for land attack missions, providing an alternative strike option with its 600-kilometer range and high-speed capabilities. On the other hand, the FREMM-Class frigates are also well-equipped for land attack missions, particularly the French variant, which carries the MBDA Missile de Croisière Naval, also known as the Naval Cruise Missile. This missile has a range of approximately 1,000 kilometers and can strike high-value targets deep inland with pinpoint accuracy. The MDCN is launched from the Silver A-70 vertical launch system, offering stealthy and flexible deployment. These missiles are equipped with advanced guidance systems, including inertial navigation, satellite GPS, and terrain-following radar, enabling them to penetrate heavily defended airspaces and strike with precision. In addition to cruise missiles, the FREMM-Class frigates can also use their 76mm OTO Melara naval guns for shore bombardment, providing close support during amphibious operations. Overall, While the Admiral Gorshkov-Class excels in long-range strategic strikes, the FREMM-Class emphasizes adaptable, precise attacks with modular missile configurations, making both frigates highly capable platforms for modern land attack operations. Regarding command and control system, the Admiral Gorshkov is equipped with an advanced command and control system designed to manage complex naval operations and multi-domain warfare scenarios. Its Sigma combat management system acts as the brain of the ship, integrating data from sensors, radars, sonar, and weapon systems to create a real-time tactical picture. This system allows the crew to monitor threats, assign targets, and coordinate weapon systems efficiently. Additionally, it supports secure data sharing and communication links, enabling seamless integration with other naval units, airborne assets, and land-based command centers. The system is known for its ability to process vast amounts of information quickly, allowing commanders to make informed decisions under pressure. The ship also features secure satellite communication systems, ensuring encrypted and uninterrupted communication even in contested environments. In terms of electronic warfare systems, the Admiral Gorshkov-Class is equipped with the TK-25E5 Electronic Warfare Suite, which includes electronic support measures and electronic countermeasures. The ESM component detects and identifies enemy radar signals and communications, providing the crew with information about the enemy's location and capabilities. The ECM system actively jams and disrupts enemy radar and communication frequencies, reducing the effectiveness of enemy targeting systems. The frigate is also equipped with chaff and flare dispensers, which act as decoys to mislead incoming anti-ship missiles. These systems provide a multi-layered electronic shield that significantly enhances the ship's survivability in electronic warfare-heavy environments. Stealth is a core design principle of the Admiral Gorshkov-Class. The ship features an angular hull design and a superstructure made of radar-absorbent materials, minimizing its radar cross-section. The exhaust systems are also designed to reduce the ship's infrared signature, making it harder to detect using heat-seeking sensors. Additionally, the placement of antennas, weapons, and other external structures is optimized to reduce radar reflections. These stealth features allow the Admiral Gorshkov-Class to operate closer to enemy forces without being detected, giving it a significant tactical advantage in contested zones. On the other hand, the FREMM-Class frigates, are renowned for their sophisticated command and control systems. They use the SETI's combat management system, developed by Naval Group, which integrates sensors, weapon systems, and communication networks into a single operating interface. This system provides the ship's command with a highly detailed, real-time tactical overview and can simultaneously manage multiple threats across air, sea, and underwater domains. The SETI CMS supports network-centric warfare, allowing the FREMM-Class to coordinate with allied ships, aircraft, and land-based assets seamlessly. The CMS is also cyber-resilient, ensuring uninterrupted operations even under electronic and cyber attacks. In terms of electronic warfare systems, FREMM are equipped with the Thales Sentinel electronic support measures and the Thales Vigil 200 electronic warfare suite. These systems are capable of detecting, analyzing, and countering enemy radar and communication signals over long ranges. For active defense, the ship employs the LaCroix Silena Mk2 decoy launchers, which release chaff and infrared countermeasures to mislead incoming anti-ship missiles. Additionally, the Sagem NG infrared tracking system enhances passive detection and threat identification, even in environments saturated with electronic interference. The electronic warfare capabilities of the FREMM-Class are considered among the most advanced in NATO navies, offering a strong defensive layer against electronic and radar-guided attacks. The stealth characteristics of the FREMM-Class are also a key aspect of its design. The hull and superstructure are built using radar-absorbent materials, and the ship features angled surfaces to minimize its radar cross-section. Exhaust systems are designed to reduce the infrared signature, while noise-reducing technologies are integrated into the ship's propulsion system to reduce its acoustic signature, making it harder for submarines to detect. The low radar visibility and minimal heat and noise emissions allow the FREMM-Class to operate in contested waters with reduced risk of detection, supporting both offensive and defensive operations. Regarding cost, the Admiral Gorshkov-Class frigate has an estimated per-unit cost of around $450 to $500 million, depending on the specific configuration and weapon systems included. Several factors contribute to this cost. In terms of lifecycle costs, including maintenance, upgrades, and disposal, the Admiral Gorshkov-Class is expected to cost approximately $1.5 to $2 billion over its 30-year service life. On the other hand, the FREMM-Class frigates are more expensive per unit, with an estimated cost of $700 to $750 million per ship, depending on whether the variant is optimized for anti-submarine warfare, anti-air warfare, or general-purpose operations. In terms of life cycle costs, The FREMM-Class frigate is expected to cost approximately $2 to $2.5 billion over its 30-year operational lifespan. The Admiral Gorshkov has seen limited production so far, primarily due to budget constraints, geopolitical sanctions, and delays in sourcing key components like gas turbines. As of now, 4 units have been commissioned into the Russian Navy, with an additional 6 units planned or under construction. The lead ship, Admiral Gorshkov, was commissioned in 2018, followed by Admiral Kasatonov in 2020, Admiral Golovko in 2022, and Admiral Isakov in 2023. These frigates are mainly deployed with the Russian Northern Fleet, operating in the Arctic and North Atlantic regions, where they perform strategic patrols, fleet escort duties, and deterrence missions. As for exports, despite being offered to potential foreign buyers, no confirmed sales have been reported. However, countries like India and Algeria have expressed interest in acquiring variants of the Admiral Gorshkov-Class frigate, though no formal agreements have been reached. On the other hand, the FREMM-Class frigates, developed jointly by France and Italy, have seen much larger production numbers due to their joint development model and strong export appeal. A total of 22 FREMM frigates have been planned, with 10 delivered to France, 10 to Italy, and 2 exported to Egypt and Morocco. France operates its FREMM frigates under 2 variants: anti-submarine warfare and air defense optimized versions. Italy operates both general-purpose and ASW variants. These frigates are deployed across the Mediterranean Sea, North Atlantic Ocean, and Indo-Pacific region, conducting missions that include anti-piracy patrols, maritime surveillance, anti-submarine operations, and humanitarian assistance. In terms of exports, the FREMM-Class has achieved significant international success. Egypt acquired 2 FREMM frigates, enhancing its naval capabilities in the Red Sea and Eastern Mediterranean. Morocco operates 1 FREMM frigate, the Mohammed VI, which has been deployed in regional security and maritime surveillance operations. Additionally, the United States selected an upgraded FREMM design as the basis for its new Constellation-class frigate program, further highlighting the platform's adaptability and effectiveness. In summary, both the Admiral Gorshkov-Class and FREMM-Class frigates represent the pinnacle of modern naval engineering, but they excel in different areas based on their respective naval doctrines. Which one do you think has the edge in modern combat scenarios? Let us know in the comments below. That's it for today's comparison. Make sure to like, share, and subscribe for more defense updates and comparisons. See you in the next video.